All right, hello everybody, welcome back. This is a lecture on, this will be the last lecture on solar and an off-grid setup and how to size some batteries. So this is a very simple presentation of this topic. It can get a lot more complicated than this. So I want to keep it simple so we have a decent understanding of what we're trying to do here, and that you can actually, on a basic level, set up an off-grid system and make a choice about batteries. So we know that a home is 120 volts. That's the alternating current system that we use in our home that is delivered to us in this area by PGE. If you have an off-grid system, that's typically going to be a 12-volt system that we can invert to 120 to make it run appliances that we're used to. But typically, and almost always, your solar panels are going to put out 12 volts, not 120 volts. And that needs to be considered when we go ahead and need to size batteries, because batteries come to us in 12 volt or 24 volt or 48 volt. So we're just going to stick with 12 volt and not let it get too complicated. I'm going to reduce myself down a little bit here. And let's just talk about these slides. See if we can make this work. So hopefully you can see that. I don't know if I've disappeared or not, but either way, let's take a look at this. So this is a off-grid system with a grid connection. So you can run these two different ways. You can run them off-grid with a battery backup, or you can run them grid-tied. So a grid-tied wouldn't have any batteries, obviously. But an off-grid system is going to have battery storage, and that's how we're going to capture our solar energy and then use it through the evening hours where there's no solar input to your solar panels. So this is just a basic setup where you have the solar panels on the roof, comes down into a DC connect, and then that connect typically goes into some kind of charge controller. So the charge controller is just going to keep the batteries from overloading. Once they're charged up and ready to go, then the charge controller is going to not send any more energy to the batteries so we don't blow them up. So normally it's a deep cycle batteries. This one looks like it has 2 deep cycles. I don't know if you can see my mouse, but they're right there. And then we would send it to an inverter, which would turn it to 120 volts for the home. So that'd be a typical home like what we have. All right, so that's the off-grid system. Let's talk about batteries a little bit. Almost all batteries that are used by photovoltaic or PV batteries are the lead acid type of batteries. Now, there's other types, there's gels, there's lithium, there's all different kinds. So I'm not going to really go into all the different kinds, but normally batteries are rated by their typical amp hours. So that kind of gives you the amount of strength that a battery has, 120 amp hours or 200 or 300 amp hours. Those are all going to be different kinds of batteries. Keep in mind that we're only going to use a small percentage of the available amp hours in a battery. We're not going to use all of it up. That's very hard on batteries. So, and they don't last that long. So, all right. So one of the things that are advertised are cold cranking amps, and that's because that's the highest amperage that you'll see in a battery. So cold cranking amps are the amps that are available to use very quickly and very fast, usually to spin a motor. So that can be anywhere upwards of 500, 600, 800 cold cramping amp hours, but it's for a short amount of time. This says 30 seconds. So that's not really what we're going to look for. We're going to look for something more like a reserve capacity or a deep cycle battery, which just doesn't have cold cranking amp hour ratings that are very high at all. So we want a lot of storage that we can distribute over time. So the reserve capacity, its number of minutes of battery can maintain a useful voltage under a 25 amp hour discharge. So 25 amp hours over time is the reserve capacity. So we kind of know what cranking amps are and cold cranking amps, and now reserve capacity. And we'll see those come to us in all different rating styles. So the image shows a 12 volt, a cold cranking amps of 775, an RC, a reserve capacity of 120, and a 20-hour rating at 550. So that's not a bad battery. It's going to be a fairly expensive battery, actually. So, and then the amp hours is just shown there on the slide, is just going to give you an idea of kind of a typical use of deep cycle batteries, right? Battery with 150 amp hour rating would provide 15 amps for 10 hours. So 10 amps for 15 hours or 150 amps for 1 hour, however you want to do that multiplication. Amps times time gives you amp hours. All right, so here's a typical deep cycle, very expensive battery. This is a group 8B. These are very big batteries, okay? And it's got a whole bunch of amp hours associated. 300 is a lot of amp hours, 12 volts. So you can see down the product details some of the information that you're going to get with the battery, right? It's going to tell you that 360 minutes about at 50 amps or 900 minutes at 20 amps. So these amps will become more obvious to you how we'll use those when we do our little calculation going from watts to amps. So here's another just picture of a grid tied system, solar panels on top, coming into a inverter. Those solar panels can feed home appliances if they're 12 volt. There's some kind of electric panel that controls everything, and then there's a meter that would send it to the grid system. So that would be a solar system that allows you to sell to the power company. So make a little bit of money off your solar system if you don't use it directly in your home. All right, inverters, what do? Well, they're going to take the given voltage, like 12 volts, and invert it to 120 volts. So a converter will take 120 and move it down to 12, right? There's micros, there's power optimizers, all just different kinds of inverters. So most of the small inverters that we're going to use are going to take a PV system 12 volts and change it to a usable 120 volt system for your home. There are losses during that process. So usually 10 to 15% energy loss in the inversion process. So here's just an example of pricing and wattage for the 12 volt inverters. So you have to choose one. You can choose one off my list if you want, or you can go on the internet and get more current pricing, because my pricing is pretty old. On your homework problem, you'll need an inverter. So just size it appropriately. You don't need a 10,000 watt inverter if you're only inverting 3,000 watts. So, all right, so here's an example of what you're going to do. I'm going to walk you through it. The basic equation for electricity and watts, amps, and voltage is watts equals amps times voltage. So if you know your amps and you know your voltage, you can calculate your watts, or you can flip it around and say, okay, well, amperage or required amperage would be the watts divided by the voltage. So if we know the watts and we know the voltage, 12 volt or 120 volt, we can come up with the amp hours required. to operate whatever we're trying to operate. So that's the project that you're going to do. And this is an example, the Timothy Lake 120 volt hunting cabin. So this is an off-grid cabin, but it is a 120 volt. Like it's got normal light bulbs and a normal heater in it. And that's all that's in this little cabin. And your tiny house can be the same. It can be very simple. I think you have to have a few more things than that, but keep it simple. All right. So what this hunting cabin has is 3 60-watt light bulbs, okay? And they're going to run 1 hour a day. So you got to know your usage or design it for a usage. So you get to choose that unless it's given to you. And in this case, it's given to us, right? We have 1 hour a day at 60 watts, but there's 3 of them. So essentially we have 180 hours, 3 times 60, for 1 hour. So 180 watts in this day is going to be lighting, right? And those are watt hours because it's per hour. Then there's also a heater, 1500 watt heater, and it's going to run 2 hours a day. So you're going to show up, in the evening after you're hunting, you're going to flip the heater on and warm the place up. It's going to run for 2 hours. So that's going to be 3000, right? So 3000 watt hours, and our 180 from the light bulbs gives us 3180 watt hours a day. That's at 120 volts. We need to 120 volt it, right? But that's the kind of calculation you want to do. Now, if you wanted to cover 3 days with your batteries, then you would have to multiply the 3180 times 3 to have 3-day backup of batteries, right? I'm not doing that here. I'm just going to do this 1 day. So we're going to size the batteries for 1 day coverage. If it's cloudy for 3 days, then we're going to be in trouble because it's not going to run for 3 days. It's going to run for 1 day. All right. So we take that AC load, the 3180 watt hours a day, and we divide it by the voltage. And this is operating at 120. So we divide it by 120 and we get 26.5 amp hours a day alternating current. Okay. We're still in AC. Now we're going to convert. We're going to convert from AC to DC. So from 120 to 12, that's a factor of 10. So we take the 26.5 and we multiply by 10. That's 265 amp hours a day of battery load, or 12 volts. We just inverted it. Okay. Now, there's some losses in inversion. It's not 100%. It's going to heat up. We're going to lose some energy. That's what the 0.89 is about. We get to keep 0.89%. That's just based on this inverter down here that says, hey, it's 0.8, it's 89% efficient, which is 0.89. So then we take the 0.89 and we multiply and we get 294, right? That means, let me just explain this, that the 265 is got to be raised up, right? If we're only 0.89 efficient. So you can do the math on that, but it's taking the, it's figuring out what the losses are and then adding them back to the original 265 to get to the 294, okay? So if you invert the 0.89 and multiply it by the 265, then you'll figure out how to get the 294. But since we're going to lose some energy, we've got to raise it up, whatever that efficiency is. So it's got to go up from 265 because we're going to invert it and lose. Looks like we lose 11% with this inverter. All right, so now we're at 294.2, and that is your amp hours per day. So if I had, a 300 amp hour battery, it would do it, barely, but it would do it. And that's how that's how we size our battery backup. Again, I didn't multiply by number of days. I didn't need the number of panels up here or 100 watt panels or any of that. All I needed was my energy consumption in watt hours, and then to convert it to the 12 and then to invert it with the efficiency, I got to 294.2 amp hours per day. All right, so that's the exercise that you're going to do, but you're going to have a few more things in there, and it'll get a little more complicated, but not a lot. Don't make it more complicated. This is it. This is what you're going to do: is design a tiny home, a 12 by 24, 2 rooms max with a bathroom. And then this is the information that's going to go into it. So I did give you the load. So you'll have to calculate it, but we want a battery backup for 3 days. You're going to design your tiny home. Choose your lights, choose your heat. And you're going to use 180 watt panels. We'll work on that later. But what I want you to do is calculate your battery backup. So it does say estimate the full cost of your solar system. We don't completely have to do that yet, but your lighting, your heating, and you can use my numbers, or you can look up some numbers, and any electrical loads in your tiny home. So keep it simple. Don't put a bunch of stuff in there, or you're going to end up with a bunch of battery backup. Okay. Like once you have your wattage that you need per day, how often things are going to be on and off, then you can get it to then you could actually size the solar system if you wanted to with 180 watt panels. So, once you get your wattage use is your wattage use. And you can come up with how much energy is going to come to this location. Did I give you location? I think I did. Near Primeville, Oregon. So you can look that up, right? And we're going to choose sunny days. And, if you have 10,000 watts, then your 180 watt panels, you can figure out how many of those you need. Now, you're going to get more than 1 hour a day. So you might get 4 hours a day or 6 hours a day, right? If that's the case, then that brings your panel count down, right? If you had 10,000 watts, 180 watt panels, but you're going to get 4 hours a day. So each panel is going to be 4 times the 180, right? So that would bring your panel count down. So you should be able to do that too. I'll put up a solution to this after you guys work through it a little bit. If you have any questions, of course, reach out and we can try to get those answered. So have some fun with this. You don't have to do a lot of elaborate graphics or anything. Just kind of sketch up your tiny home and come up with your usage. Find out how much sun is coming near Primeville, Oregon on December 21st. 1 p.m. and see how much solar energy you're going to get per day. And then you have your 180 watt panels. See how many you'd need to cover that. And it looks like we want a 3-day backup on the battery. So, all right, that's a lot of information. So hopefully my example will help you and you can work your way through it. All right, I will talk to you on Wednesday. Have a good couple days.